Ladies and gentlemen, in my Physics 4A class, today I'm going to do some problems for you from chapter 8 and of course from chapter 7 too. It's about circular motion, it's about overall dynamic of circular motion, chapter 8, and dynamic on x and y axis also. So these questions are from your book, chapter 8, and as you see, you do have the numbers. What it says below figure, two wires are tied to 300 grams sphere. So this mass is 300 grams. So let me write it that mass is 300 grams divided by 1000 will be 0.3 kilograms. The sphere revolves in a horizontal circle, so it makes actually circular motion. So remember what we need to do in reality. So this makes circular motion, okay? So because it makes circular motion, therefore we need to find, don't forget, the radius always. Maybe it's given, I don't know what question says yet, but we need to find always the radius. Let's see, maybe it's given. With constant speed of 7.5 meters per second, so the rotation speed, which it is in reality tangent velocity, correct? Because object rotates on the circle, so tangent velocity is 7.5 meters per second. What is the tension in each of wires? So guys, it doesn't say tension is equal because we have two strings, the top one and the bottom one. We have to have two tensions. That's why one I call it T1, one I call it T2. Then it says, yeah, what is the tension on each? Okay, so I don't have radius. Remember, the first thing that you have to do in the part of circular motions, dynamic of circular motions, you have to know radius of rotation. What is the radius? You know, what we have in this triangle, correct? So I can say this is my triangle. I'm sorry if I don't make the line straight. Oh my gosh, this is so bad. So let's say this is the, let's make that triangle. Okay. Alright. Almost. So this is R, correct? Little r or big R doesn't matter. This one is 0.5 meter. And I do have hypotenuse, which is 1.0 meter. Can I find radius? Yes. So very quickly, I can say 1 squared by Pythagorean is 0.5 to the power of 2 plus r squared. Therefore, the radius will be found. So if I do 1 minus 0.5 square, then take square root 0.86. So it's 0.86 meters, or 87, doesn't matter. Okay. And also, I think I need to find this angle, the most probably I have to. Okay, let me see what is that angle. Just find it, maybe we need it later. So if I find the angle, can I say sine theta is opposite? Or sine is not going to help me, huh? Yeah, that's okay. Is opposite divided by hypotenuse. So sine theta will be opposite. What is the opposite? It's r, correct? Hypotenuse, it's 1. We know r, which it is 0.86 divided by 1. It's 0.86. Therefore, if I find theta, will be sine inverse 0.86. Which if you do this, sine inverse 0.86, sine inverse 0.86. What is wrong? Sine theta is opposite divided by hypotenuse. Opposite is 0.861. My calculator is not in degrees. Okay, sine 90, it has to be 1. So sine 0.86, the answer becomes 59.32 degrees. So that's my angle. Okay. So here are important things that always we have to find the radius, which is important, and also angle. Okay. The next thing is, guys, what we have to do, verify all forces. Okay, very quickly. Let me do by this. Watch, guys. Always. What is this force? Mg. It's force of weight. Then what I have here, I do have tension 1, and also what I have here, I do have what? Tension 2. I do not have normal force. Why? Because it is there is no contact surface. So now I need to verify my RTZ system. Look, guys, R, here is the center of rotation. Here is the center, correct? Toward the center, so here is my circle. So radial axis is this. This is my radial axis. Tangent, remember RTZ coordinate system. Tangent is on the circle and Z is up and down. So in reality, this is my Z axis. Now, what do I see here? I can see actually, if this is theta, this angle also by geometry will be theta, okay? Therefore, this tension makes two components. one component is, here will be T1 cosine theta, and the other one, it's on x-axis or on r-axis, will be T1 what? Sine theta. Same thing I am going to have for tension 2. So this is also theta. This will be also theta. Therefore, here I am going to have T2 cosine theta, and this will be T1 sine theta. Then, after we finish these, we will apply sigma f on r-axis equal mv squared over r. Sigma f on tangent axis is 0. Why it's 0? Because tangent velocity is constant. So there is no tangent acceleration. And also sigma f on z-axis is 0. Now we will apply these three. Let's see. First of all, it says sigma f on r-axis. That means is how many forces do I have on radial axis? I do have only two arrows. One is black, one is red. This one is just your axis. Don't say this is force. So on radial axis, sigma fr means is total forces on radial axis. How many forces do I have on radial axis? It's only two. It's T1 sine theta and, sorry, this is T2. This is T2. And T2 sine theta. So both they are toward the center. Toward the center is positive direction. So I'm going to have T1 sine theta plus T2 sine theta equal m v squared over what? R. This is on radial axis. On tangent axis, I don't have any force, so this will not help me. I don't have any force, so the second one doesn't help me. What about third one? How many forces do I have on z-axis? I have one, which is T1 cosine theta. One is T2 cosine theta, one is mg. Anything up is positive, down is negative. So I'm going to have T1 cosine theta. T1 cosine theta is positive, minus T2, minus T2 cosine theta, correct? Minus mg equals 0. Am I right? Yes. But let's save the time. So move mg over. So this will be equal mg. Make sense? Now guys, because I want everything to be on one page, I'll try. Now let's substitute. So I can say, okay, I can factor with sine theta, which is sine a 59.32. Okay, that is a number. T1 plus T2 equal m v squared over r. And then here I can also factor with cosine 59.32. T1 minus T2 equal what? mg. Now let's substitute. So I am going to have T1 plus T2. What is sine 59.31, 0.85, mass is 0.3, V, as question says, is 7.5 to the power of 2, and R is radius, big R, little r doesn't matter, 0.86, correct? In the same time, I am going to have T1 minus T2, cosine 59.32 is 0.51 equal, m is 0.3, g is 9.8, therefore I am going to have this T1 plus T2 becomes this 0.3 times 7.5 square divided 0.86 divided by 0.85, correct? So this will be 23.08. And what about T1 minus T2? I am going to have 0.3 times 9.8 divided 0.51, 5.76. So this is a set. We can find tensions. It's up to you. You're free to do anything. You can substitute, you can cancel. So I go with elimination date method. So I'm gonna add these two. So if I add these two, let me see, tension 2 with tension 2 gone. So I am going to have 2T1 equal that plus 23, 28.76. If I do divided by 2, T1 becomes what? 14.38. When I do calculations, I don't go with 2 decimal point. I go with any number shows, then I do divide it by 2. So if you go by 2 decimal point, you may get a little bit very small numbers off, but it's okay. When we found T1, substitute in this one, for example, then you can find T2. The answer will be 23.08 minus 14.38. Answer is 8.7 newtons. So here is, we found tensions in both strings. So what we see here, guys, the length of strings are same. The distance from center to strings is same, 0.5, 0.5, length is 1. But we see tensions are different. It's completely obvious that the tension on the top string and the upper string on this one will be more than this. Why? Because it tolerates actually more gravity than this one. So more tension is on T1 than T2. And we see it in calculations that T1 is greater than T2. Okay. I will add another section for this problem. Let's say find angular velocity of ball by RPM. Okay, by RPM. Find angular velocity. So what is angular velocity? It's omega. Oh, what is the relation between omega and Vt? We know Vt is equal with what? R omega. Therefore, what is Vt? We can solve it. We know Vt. So omega will be Vt divided by R. Therefore, omega becomes, what is Vt? 7.5. What is R? We found it. It's here. 0.86. So if I do that number, 7.5 divided by 0.86, the answer is 8.72. 8.72 radians per second. This is in metric system. Remember, omega is always by radians per second. But it will be very good that we can find it also by RPM. Because when we say RPM, it's more sensible, it's more tangible, it's more touchable. We know RPM, so it's rotations per minute. So for that reason, you should do this. This is 8.72 radians per second. You want to convert it to revolutions per minute. So you have to write here revolution, here radian, then revolution per minute will be here, then second will be here, correct? Therefore, 1 revolution is 2 pi radian, 1 minute is 60 seconds, so your answer will be 8.72 times 60 divided by 2. What's that? 8.72 times 60 divided by 2 pi, 83.3. So omega becomes what? 83.3 RPM. This is another good practice, that you can find radians per second to RPM. Before we did RPM to radians per second. Any questions? So I want you to redo this problem, please. It is very important to know how to do it. Let's see what is the second question. Question number 2, it says, it's question number 8 in your book. It says, in the Bohr model of the hydrogen atom, an electron mass is 9.1 times 10 to negative 32 kilograms. Orbits a proton at a distance of 5.3 times 10 to negative. So this is nothing, okay? And this too is nothing. I don't know where they come from. So in the Bohr model of the hydrogen atom, an electron, so mass of electron is 9.1 times 10 to negative 31 kilogram. Orbits a proton. So as you know, guys, the structure of atom is actually like, you have a small center, which is called nucleus, and then electrons orbits nucleus. So this is proton or nucleus, and here electron orbits the nucleus. So proton, inside the nucleus we have protons and neutrons, but for hydrogen atom we have one proton. So what it says electron orbits at this distance. So this distance is very small, little r or big R, which is radius. So it is 5.3 times 10 to negative 11 meter. The proton pulls on the electron with electric force. We will go over this topic of electric force in physics for free. So the proton pulls on the electron with an electric force of, so that force is 8.2 times 10 to negative 8 newtons. How many revolutions per second does the electron makes? So N means is number of revolution. What can we do? An electron mass is this. Then it says we do have force, which that force is, of course, because electron is negative, proton is positive, so it will be an attractive force like gravity. And because electron has speed, so electric force acts like centripetal force. Alright, what can we do? How many revolutions per second? What is number of revolution per, okay, when it says number of revolution per second, in reality is what? This is same as omega. Revolution, it's radian, the unit is radian per second, correct? So what can we do? So let me erase this n, you will confuse then with number. Alright, so F, its centripetal force, it's m r omega squared, because they want me to find omega, so I'm going to use the first section, this definition. Therefore, F is 8.2 times 10 to negative 8. Mass is 9.1 times 10 to negative 31. Radius is 5.3. Times 10 to negative 11, correct? M, R, then omega squared. So let's solve it for omega squared, then take square root, find the answer. So 8.2 times 10 to the power of negative 8, that number, divided by 9.1 times 10 to the power of negative 31, parenthesis close. Then that number divided by 5.3 times 10 to the power of negative 11, close parenthesis. Then take square root of that number, will be 4.1 times 10 to 16 4.12 times 10 to 16 radians per second. Okay, now if I find it by rotation per second or revolutions per second, so this is in metric system, radians per second. So I will say that number, I think I did mistake, yeah, this is 16, sorry, times 10 to 16. Let's say this is radians per second. I want to convert radians to revolution. Here is radian, correct? One revolution is 2 pi radian. Second is second, so my answer will be that number divided by 2 pi, correct? Yes. So it will be 6.56 times 10 to 15 revolutions per second. Number of cycles per second. Okay, let me tell you this. Number of cycles per second. In 1 second, it's called frequency. Do not forget this. We showed by little f. So when it says 6.56 times 10 to 15 revolutions per second, in reality, this is the frequency of rotation. Frequency of rotation. Okay? Yes. Now, let's go here on question number 7 in your book. Physics for Scientists and Engineers, Strategic Approach, 4th edition. Okay? This is your book. Same thing. It says a 200-gram block on a 50 centimeter long string swings in a circle on a horizontal frictionless table at 75 RPM. So what it says, in reality, it is something like this. So what I do have a 200 gram, so mass of that ball is 200 grams, okay, 200 gram block with 50 centimeter long string. So here is the center, correct? Then guys, what I have, this is my radius, correct? So it says radius is 50 centimeter, 0.5 meter, swings in a circle on horizontal frictionless table. So here we have a table. So friction force is 0. "75 RPM, what does that mean? What I have to write, what is equal with 75 RPM? What does RPM means? omega. Don't forget this, please. So very quickly, you have to convert this one to radians per second. Multiply by 2 pi divided by 60. 1 revolution is 2 pi radian. 1 minute is 60 seconds. So if you do that, don't forget it. If you see RPM, you have to convert it to radians per second with no exception, unless they want you to do something. So times 2 pi divided by 60. Answer is 7.85. I'm sorry, one moment, let me answer. Somebody emails me, students, to okay. Now, what is speed of block? So they want you to find what is the speed of block. What is the tension on the string also? That will be part 2. Okay, guys. You have omega, you have radius very quickly. What is Vt? Is it not R omega? Therefore Vt will be what? R is 0.5. And what is omega? 7.85. So let me write here. Radians per second. So yes, that number times 0.5 will be 3.93 almost. Meters per second. This is Vt. Then they want you also to find tension. Okay, pay attention. Guys, this is a string. This red one is a string. So here is your hanging point, the hanged point. Remember, tension is always toward what? Hanged point. So here what I see, this is my radial axis. And T is on the circle. See, this is Z axis. And T is on the circle. So it's like this. R, my middle finger is R, index finger is T, and Z is thumb finger is up and down. Correct? RTZ. So if I apply sigma FR equal what? M R omega square, correct? And also I have sigma F on tangent is MAT, and also sigma F on what? Z-axis is 0. Let's apply all of these. Watch it. On radial axis, how many forces do I have on radial axis? It's only one. It's only tension. Listen, some students, they say, okay, we have tension and we have centripetal force equal blah blah. No. This, who's making this tension? It's centripetal force. That's why you have rotation. So do not put this one here, please. Okay? Therefore, so the only force that I have on the circle, on the radial axis is tension. So tension is equal with M is 0.2 0.2, what is radius? 0.5 What is omega, guys? 7.85 to the power of 2. So tension becomes how much? If we do that, 0.2 times 0.5 times 7.85 squared, the answer will be 6.16. So 6.16 newtons is your tension. Did you get this? So we found tension and also we found speed of block. Number 22. It says student has 65 centimeter long arms. What is the minimum angular velocity in RPM for swinging a bucket of water in a vertical circle without spilling water out any? The distance from the handle to the bottom of the bucket is 35 centimeter. Okay, let me draw one bucket. Watch, guys. So let's say here I have then also I do have what? The handle of this bucket, correct? Then student, oops, let me see. So then student, he has his hand, okay, let's say, and he is, imagine, assume that this is student's hand, and this is his arm actually, and here we have water, correct, at the end of bucket, let's say, and the length of arm, as the book says, its student has 65 centimeter, so this is 65 centimeter, correct? And also this distance from his hand, see, what is the minimum angular? Okay, the distance from the handle to the bottom of the bucket is 35 centimeter. Okay, so let's say this is 35 centimeter. Question is this, so it rotates, so here is your center of rotation, correct? Question says what is the minimum angular velocity? So omega must be how much? Actually this is omega minimum, must be how much to this water could stick on the end of bucket, not fall, not spilling out. What can I do? So the water must have, actually bucket must have a proper velocity, proper speed to can keep the water on the end of bucket. If not, water will fall down, water will, spill if we don't have enough rotation. Like if the moon doesn't orbit the earth with speed that it has it now, if speed decreases, moon will fall on the earth. Listen, the earth orbits the sun with almost 30 kilometers per second. Earth orbits the sun almost with the average velocity of 29 point something, so let's say with 30 kilometers per second. If earth goes, for example, with 25 kilometers per second, what's gonna happen? So let's say this is earth and here is the sun. Earth orbits the sun, correct? If rotation, if tangent velocity decreases by the time, finally the Earth will be closer to the sun and finally will fall on the sun. That's why the water must have enough velocity to could stay at the end, on the end of bucket. If not, that water will fall. So they ask you, what is minimum rotation? What can I do? What do you think? So think about it, please. Okay, you have to remember always you are in RTZ coordinate system. First of all, verify radial axis. Okay, this is radial axis, see? Toward the center. Object rotates. So object is here, toward the center is radial axis. Am I right? Then T is this. This is tangent axis. It's orbits. And Z will be up and down. So Z will be inside the board. So let's verify forces on radial axis. Okay, first of all, what do I have? I do have mg. Yes or no? And also, because here I have normal surface, for I have surface, I have contact, I am going to have what? Fn, normal force, which Fn forms from bucket underwater, from this bucket, surface of bucket underwater. Therefore, if I apply sigma F on r-axis equal mv squared over r, or m, what is the minimum angular velocity? Yes, in rpm, or mr omega square. So if I apply this with the vector, how many forces do I have on radial axis? Is it not 2? Are they positive or negative? Negative or positive? Which one? Actually, both they are positive. Why? Because they are toward the center. Toward the center is positive. So I am going to have mg plus fn is equal with what? M r omega square. Correct? This is my equation. Now, guys, pay attention. It says, what is the minimum RPM? Find minimum rotation, minimum omega. Okay, pay attention here. If I want omega to becomes minimum number, see, if we want omega to be minimum number, this tells me that Fn must be what? 0. By physics, this is by math, but by physics is this. Guys, Fn actually pushes the water down. So Fn is the force that forms from the surface of bucket underwater. Remember, what is Fn? If you have a surface contact or contact surface, so this is surface, all right? This is mg, this is Fn. Here, Fn is upward, mg is down. What if, pay attention here, what if I have surface like this and object like this? What I have here at this time? Of course I have mg down, and of course I have what? Fn, because Fn is force from the surface on the object. That's why Fn is down. So we want to ignore that. We want to delete that force. Because Fn pushes the water down. So we don't want to have that. That's why Fn must be what? 0. When this happens, so here my equation becomes mg plus 0 equal mr omega square. Therefore, my goal is finding omega. So you see, guys, so I'm going to have mg equal mr omega square. Therefore, this m with this m gone, it's not up to the mass of water. Don't say we should have less water. No, you see the mass cancels each other. So omega square becomes what? G over R. Actually, this is a very good problem. So omega becomes radical G over R. So number of revolutions per minute depends on gravity of planet, gravity of the location, and if little kids they do this, you know, it's completely, they will get different omega of it if the tall guys they do it, because you know, depends on the radius of rotation. Does make sense? Therefore, I can substitute omega will be radical G is 9.8. What is R? 65 plus 35. It's 100 centimeter. It's 1. So let me write that R is 65 plus 35. Answer is 100 centimeter, which it is 1 meters. That's why I substitute instead of R 1. Okay, so if you take square root of omega of G, remember will be pi number. Watch. Square root of 9.8. The answer is 3.13 something, close to pi number. So omega is 3.13 radians per second. But the book wants me to find it by RPM. So then omega will be 3.13 RPM. So here, let me do this. So radians per second times revolution per minute. Minute must be here. So here radian, here second. 1 minute is 60 seconds. 1 revolution is 2 pi radian. Therefore, if you do 3.13 times 60 divided by 2 divided by pi, 29.9. Wow. RPM. So omega becomes how much? There you go. This is your problem solving for this question. All right. Okay, this problem, I have to tell you something about gravity, so not yet. Take break for 3 minutes, I'll be back. Okay. Okay, guys. 55 to 59. Here it says a highway curve of radius 500 meters. So what we do have a highway curve. Okay, so of course it has the center, so radius is 500 meters. Is designed for traffic moving at speed of 90 kilometers per hour. So that speed is 90 kilometers per hour. Which very quickly we have to convert it to meters per second because it's not metric. So 1 kilometer is 1000 meters and 1 hour is 3600 seconds. So if you do that, 90 times 1000 divided by 3600, it's 25 meters per second. So this is your VT. Okay. What is the correct banking angle of the road? What is the correct banking angle of the road? Okay. Here in this problem, in reality, it's they assume it's. Do you remember in the lecture I went over two if? One if number one was if we don't have friction force. It was the worst case. The second if was if our curve is flat instead of banked. So here they assume that friction force is what? 0, which is the worst case actually. So, and equation that I found that it was this: tangent theta is v square over rg, correct? So we got this equation from that big formula. Therefore, so I can, they want me to find theta actually. Theta is unknown. What is this banked, yeah, angle? What is that theta? So if I solve it for theta, theta becomes what? Tangent inverse v square over rg. Therefore, theta becomes tangent inverse. What is v? 25 to the power of 2. R is 500. So if I take that number, tangent inverse 25 square divided by 500 times 9.8. I got 7.27. 7.27 degrees. This is called banking angle. Make sense? So this road is designed, it's actually made by 7.27 degrees. And radius of this curve is 500. So if we find how much is the maximum speed that this car can go, it's 90 kilometers per hour. Which 90 kilometers per hour, it is something like 60 miles per hour around. Okay? If it goes by 91 kilometers per hour, this car will slide out of the curve. So this is sliding out. If it goes more than 90. I think I did discussion about this enough in part of lecture. Right. Let me see, is this one also? Yeah. Okay. Okay, let's do this problem. Again, let's say we have what? Let's say this is planet Earth. Okay. And here, moon. Okay. Works. All right. Let's say this is moon and this one is Earth. Okay. So it says mass of the moon. So I'm going to write mass of the moon is 9.4 times 10 to 21 kilogram. This is mass of the moon. It says orbits a distant planet in a circular orbit of, is it about Earth? Let me see. No, it's not about our planet. Let's say it's different planet at all. So it's another planet. It's not Earth. It's just a planet. The orbital radius is 1.5 times 10 to 8 meters. It experiences gravitational force, which it is attractive force, this one, by 1.1 times 1.1 times 10 to 19 newtons. 1.1 times 10 to 19 newtons. Okay, now what is happening? It says what is the moon's orbital period in Earth days? The moon's orbital period, so it's T. This T is not tension, you know, it's the period. So the period also we short by T. Okay. Now, what can I do? Okay, the only force is what? Radial force or centripetal force, which it is mr omega square. Where is the period? Omega is 2 pi divided by T. Remember this equation. Omega is 2 pi divided by T. So if I need to find, so this T is period, it's not tension. Some book shows also by P, some book shows by T. So I go with T, okay? Because we need to find period, I am using this section of equation. So I do have Fr, I do have mass of the moon, not mass of the planet, mass of the orbital object. So this m, remember, it's mass of orbital object, the object that rotates. Don't forget. So that's the mass of moon here in this example. So m is known, radius is known, omega, therefore omega square will be Fr over mr, correct? So let's find omega square is Fr 1.1 times 10 to 19. M is 9.4 times 10 to 21. And radius is 1.5 times 10 to 8. If I find this number, 1.1 times 10 to the power of 19 divided by 9.4 divided by 1.5 divided by 10 to the power of 21 plus 8, 29. Is that correct? Yeah. Then take the square root. I find omega is 2.794 times 10 to negative 6 radians per second. This is omega, excuse me guys. Then we know omega is 2 pi over period. So period will be 2 pi divided by omega. Therefore, t will be, if I do that number divided by 2 divided by pi, then if I inverse that number, reverse it, the period becomes this. 22, 49, 537, let's say, second. So that's mean is this one complete cycle. What is t means is time. In reality, definition of period is this. It's time for one cycle. This is definition of period. Time for one cycle. It takes 2,249,537 seconds. It takes time for one complete cycle of this moon around that planet. Let's see how many days is. What I have to do? I have to do that number to days. First let's do it to hours. So that number, which it is by second. Here I'm gonna write second. So here is hour. 1 hour is 60 seconds. Correct. Then hours must be converted to days. Correct. So hours here, days here. They say by Earth day, you know, 1 day is 24 hours. So if I do that number divided by 60 divided by 24, 1562 days. Woohoo! So I don't know what planet is this, but our moon in our solar system, Earth and moon, our moon and our planet Earth, the moon orbits the Earth in 30 days, 29.7 days. But this moon takes 1,562 days for one complete cycle. Wow. Did you get this problem? Okay. Now, this is what we learned. Question number 24, it says a 500-gram ball swings in a vertical circle. Okay, so at this time you have vertical circle. Something like this. So this is, I am assuming it's circle. Now, a 500-gram ball swings in vertical circle at the end of 1.5 meter long string. So here what I have, I actually have something like this. Okay. There you go. So 500 gram, so mass is 0.5 kilogram, swings in a vertical circle at the end of 1.5 meters. So this radius is 1.5 meters. When the ball is at the bottom of the circle here, the tension in the string, so at this situation, the tension, so this is tension, not period, be careful, or force of tension is 15 newtons. What is the speed of the ball? They want you to find what is speed means is tangent velocity. Okay. You know what to do. Very quickly, you have to tell yourself this. Oh, this is center. Radial axis is this direction, correct? It's toward the center. Yes. Verify forces. Okay. What is this one? mg. There is no Fn because there's no surface. Then, what is this one? It's tension force. It's toward the center, and why? Because it's toward the hanging point. It's like bucket problem. 2 questions before this that I did it. What is speed? Very quickly, you can apply sigma F on R is equal with what? M V square over R. How many forces do you have toward the center? Only one. That is tension. So I'm going to write a tension force. Or T, doesn't matter. It's positive, yes. Minus anything outward of the center, mg, equal mv square over r. Therefore, what they want. What is the speed of the ball? Okay, substitute 15 minus mass is 0.5, g is 9.8, mass is 0.5, speed is unknown, and radius is 1.5. Correct? So, find speed. So if I do 15 minus 0.5 times 9.8 times 1.5 divided by 0.5, then take square root 5.5. So V becomes 5.5 meters per second. If I ask you to find what is angular velocity, omega, your answer is Vt equal R omega. So omega will be Vt divided by R, 5.5 divided by 1.5. Is that 1.5? Yes. 5.5 divided by 1.5. Answer 5.5 divided by 1.5. 3.7, let's say. Radians per second. Correct? Any questions so far? Okay, this is very good problem. It says 3 cars are driving at 25 meters per second along the road shown in this figure. Car B is at the bottom of a hill. Here is car B. And car C is at the top. Both hills, they have same radius of curvature. Suppose each car suddenly brakes hard and starts, where is that, to skid. What is the tangential acceleration of each car? This is very good problem. So they want you something new, tangential acceleration. Watch it. Here Vt is not constant. Why? Because friction excuse me, exists. Okay, so I call This road has 3 sections. Part 1, part 2 is the bottom of hill, and part 3 is the top of hill. Okay, so I draw a picture for each section, please, here. So here what I have, part 1. Okay, so this is for part 1. Let's verify forces very quickly. That's your first job. This is mg, this is Fn. Yes or no? Oh, and also I have friction force. I don't have engine force here. Why? Because question says the driver suddenly brakes. So if it brakes, the pushing or pulling force of engine is 0. So no. Okay. So let's find, first of all, see what is dynamic means? Sigma F is equal what? MA on both axes. Actually on all axes here I have. Okay. Then why doesn't work? Then first I have to find friction force. So I know that friction force is what? It's mu Fn. So I have to work on Fn. Fn is on y-axis. On y-axis I don't have motion, so sigma F on y-axis is 0. Therefore, I'm going to have Fn minus mg equals 0, and then Fn becomes equal what? Mg, correct? And then friction force on part 1 becomes mu Fn, mu times mg. This is what we learned, correct? So if I substitute to find it, mu is, here is mu k, is 1 mass of the car. You don't have the mass? No, that's okay. I keep it like that. So it's just Ff is mg. Now I have to apply sigma f on x-axis, correct? How many forces do we have on x-axis? Only one. What is that? It's friction force. Your car goes this direction, in opposite direction, so that will be minus Ff equal ma, oh sorry, this is ma, because you have acceleration on x-axis. So it's equal with ma, which it is tangent acceleration, correct? It's acceleration on the surface, on your line. Therefore, what is going to be Ff here? Ff is mg equal ma. Then for section 1, acceleration becomes what? Minus g. So a in part 1 becomes negative 9.8 meters per second square. Correct? This is in part 1. Part 2, your road is like this. This is my road, and my car is here actually, correct? Let's verify very quickly forces. What is this? mg. What is this one, guys? Fn. Your car goes on tangent axis, correct? So my friction force will be in opposite. This is ff. Pay attention here. Now here, in part 2, again, I have to find sigma f on radial axis equal m. Sigma f on radial axis equal m v square over r. Sigma f on t-axis is, it's not 0, sorry, it's mat. And sigma f on z-axis is 0. Now, here, how many forces do we have on radial axis? Remember, the center is here, because this is your curve. I have 2 forces on radial axis. Anything toward the center is positive, outward is negative, so it will be Fn minus mg equal what? mv square over r. Okay. Now, what about by this one? How many forces do I have on tangent axis? I have only one, which it is in opposite direction of motion, equal mat. And this one doesn't help me because I don't have any z-axis, I don't have any forces on z-axis. Now I'm going to use these. Watch, guys. By the first one, Fn becomes what? mg plus mv squared over r, correct? And we know the second one, we know friction force is what? Mu Fn. So in the second one, I will get minus mu Fn equal what? mat. Therefore, my goal is finding at, so I will solve it. Minus mu is mu. What is Fn? What is Fn? mg plus mv squared over r. So this mu Fn, instead of Fn I substitute this, equal mat. Therefore here at becomes what? Mu with mu is 1. This m with this m I can factor it. Correct? Then this m with this m gone. So at becomes what? Minus g plus v squared over r. Good? Now if I find the values, g is 9.8, g is 9.8, velocity 25 meters per second, 25 to the power of 2 divided by radius picture says 200, say 200 meters. So tangent acceleration on part 2 becomes what? 25 squared will be 625 divided by 200 plus 9.8. The answer is negative 12.92 meters per second square. Yes. Let me do part 3 with different color. In part 3, actually your curve is like this. So your car is here. Let's verify forces very quickly. This is mg. Here is your center. This is Fn. And here is friction, because car goes this direction, correct? It's friction force. Now I have to apply sigma F on r-axis equal same thing as the top one. How many forces do I have on radial axis? mg is positive toward the center minus Fn equal mv squared over r. Therefore, Fn is, what is Fn? Is mg minus v squared over r. This is Fn. Move Fn over, move mv squared over r. Factor with m will be that. Then sigma f on t-axis is mat. So I am going to get what? How many forces do I have on tangent axis? Ff. But it's in opposite direction. Correct? What is Ff? It's minus mu Fn equal mat. Therefore, substitute. Mu Fn is what? Mu. You have to redo these problems very carefully. Mu Fn is mg minus v squared over r equal mat. Then m with m cancel, so at becomes minus g times what? No. Let me see what I did. At becomes what? M with m gone. Mu is 1, correct? G minus v squared over r. Mu is 1, you know? So mu is 1. Picture question says. Now if I substitute 9.8 minus 25 squared divided by 200, but you know what? This should be minus. The answer will be negative 25 squared okay. So answer is 6.675 meters per second square. Now that's all. That's all. This is 80. So here what we see, it's same question as Ferris wheel. So when it is flat, your acceleration is 9.8. When you are at the bottom, acceleration is very big number. It's big. That negative, it's just direction. On the top, you have that. So this question tells me when you are on the bottom of hill, you feel very heavy. But when you are on the top of the hill, your weight decreases because Fn decreases. Important thing, if you go with high speed, like if you go, for example, with 40 meters per second, your car will fly out. So in that time, if you put a scale, bathroom scale under your legs, the number will be 0. That means is you are flying out. You don't push the scale. It is weightlessness. Make sense? So this question is very similar to Ferris wheel and very similar to elevator question. Hope you liked it. Okay. This question. A concrete highway curve of radius 70 meters is banked at 15 degrees angle. So radius of that curve is 70 meters. 15 degree theta is 15 degrees. What is the maximum speed which mass of the car is 1500? Can take the curve without sliding out. Radius is 70, theta is that. What is V? You know this mass is extra data. It's just for trick. It doesn't matter. You take the curve by heavy 18 wheels truck or just by very light car. It's not up to mass. So this mass is just trick. So you know equation. Tangent theta is what? V squared over RG. Do you see any mass in this equation? Answer is not. So tangent 15 is equal with V squared over radius is 70, G is 9.8, therefore we can find it. 70 times 9.8 times tangent 15 degrees, then take square root, will be, so your speed must be 13.55 meters per second. If we want to convert it to miles per hour, this is your answer, okay? But let's see. So meter, miles, correct? 1 mile is 1609 meters. Then I'm gonna miles per hour, correct? So hours here, second here, 1 hour is 3600 second. So if you do that number times 3600 divided by 1609, it's almost 30.4 miles per hour. So if you go with 32 miles per hour, your car will slide out 100%. Okay. So guys, question number 56. and 51 and 45 in your book, chapter 8. One more time. 56, 51, 45. Do them. Do them. They are very important. And send the picture for me, please. So question number 56, 51, and 45. You work on them and send them to me, please, all. So please work on these problems. This is the same thing as the first question that I did. Just you need to know a little geometry. Okay, let me do this problem for you. Let me cover the camera. It says a 100-gram ball on a 60-centimeter long string swung in a vertical circle above the point of 200 centimeter above the floor. So this is, height. The tension in the string when the ball is at the very bottom of the circle is 5 Newton. So what we have, it says the tension in the string when the ball is at the very bottom of the circle is 5 Newton. So at this situation, tension is toward the center. So tension is what? 5 Newton. Okay, so this actually, we have to very quickly verify forces. There's no F and that's tension, so therefore here I can say anything toward the center is positive. So T minus tension minus mg equal mv square over r, correct? Therefore, I do have tension, I do have mass, 0.1, I do have g, I do have mass, I don't have a speed, oh okay, and I have radius. So using that equation, we can find speed of rotation, which is same as what? Tangent velocity. So this is speed of rotation or rotation speed. Let's see. 5 minus 0.1 times 9.8. Answer is 4 point that. Divided by 0.1, divided by 0.6. Take square root. There you go. So this is 8 point what? 18 meters per second. Now read the question, see what it says here. It says, very sharp knife is suddenly inserted as shown in this figure to cut the string directly below the point of support. Okay. So what it says, very sharp knife is suddenly inserted to cut the string directly where? Below the point of support. Where is the point of support? Here is the point of support. below the point of support. So here is the point of support. Here is the location. Here is the point that the ball actually will be released. So here at this time, let me do another circle. See, watch guys. So when the ball is here, there is no tension at this time. Tension is gone. So what is happening, this is your surface. Ball will go on tangent velocity until what? Makes like projectile motion. This VT, we already found it. It's 8.18 meters per second. Watch, by the picture, this height is 200 meters. This height is 60 centimeters, correct? Then you tell me, how much will be this? 200 minus 60, correct? 140 centimeters. What question wants? How far to the right of where the string was cut does the ball hit the floor? So they want you this distance, x. This is very similar to problems chapter 4, projectile motion. So what we have to do, we know that x equal what? Your velocity is only on x-axis. X is v naught x t, correct? We have v naught x, which is 8.18. I don't have time. My time, which is flying time. What equation I can use? You know it. Y equal 1/2 gt squared plus v naught y t. Correct? Then y is 1.4. Y is 1.4. Half is half. G is 9.8. T is unknown. What is v naught y? 0. We don't have velocity on y-axis. Only velocity is on x-axis, correct? This is only on x-axis, remember. Therefore, this flying time will be found. Let's see how much is. 1.4 times 2 divided by 9.8. Take square root. The answer is 0.534 second. 534 second. This is this. Okay? When we found flying time, done. We can find what? X is 8.18 times 0.534. That number times 8.18. The answer is 4.37 meters. So this is our X. Did you get this? It is important problem. It is a very good problem. Okay. Work on problem 51 from your book carefully, please, and also 45. So these two questions, they will be as your quiz number. I think it's 6 or 7. I'll check it, but it's 6. These two questions, number 51, chapter 8, 45, chapter 8, will be as quiz number 6, due date for me. Today is April 1st. Tomorrow is Thursday, Friday. Okay. I will not accept any late homeworks. Please work, study. I will post you some problems more, and next week Wednesday is your exam. Do not forget it, please. Thank you. Have a good day, good evening, good night. Be healthy, be safe. Bye, guys.